Welcome to this episode of Spacecraft Guide, the channel that describes how the most historic spacecraft works. This week we will be going over the components on the electrical panel that we added. Also, we will be going over how Apollo 13 used the Lunar Module's inadequate electrical power to do the incredible. This week we worked on a new panel. This is the electrical panel. Now, the switches we're going to work on, or that we worked on this week to show you, are the volts indicator, the amps indicator, and the battery fault component caution light. The first component we're going to look at is the volts indicator. When you click on it, it displays voltage of the 6 electrical power system batteries, the commander and the lunar module pilots, DC buses and AC buses for the EDS batteries, depending on the setting of the power temp monitor switch. And then the green band goes on that on the gauge from 35.8 to 37.7 volts DC on the volts indicator, which is equivalent to 112 to 118 volts AC. The range is from 20 to 40 volts DC and 62.5 to 125 volts AC. Next, we have the amps indicator, and when you click on it, it takes you to the amps indicator. Now, it indicates current flow through each of the 6 electrical power system batteries and the cross EDS batteries, depending on the setting of the power temp monitor selector switch. The range is from 0 to 120 amperes, and the amperage of the descent batteries, numbers 1, 2, 3, and 4, is obtained by having the indicator reading, which means you cut the indicator reading in half. As with any of these switches in the exhibit, what you can do is click on these links here to find even more information. General takes you to where this switch fits into the electrical system. Non-normal operations is to show you how the system works when it is operating incorrectly. Normal operations is when it operates normally. Schematics is to show you how it looks in a pictorial view within the system, and then the limitations of the system where it breaks. So all you have to do is click on one of these sections and it'll take you to the diagram to explain where it fits into the system. The final component we did is the battery fault component caution light. And when you click on that, the battery fault component caution light page comes up. And it states that what the battery fault component caution light does is it goes on when any malfunctioning battery is selected with power temp monitor selector switch. When lit, indicates reverse current, overcurrent, or over temperature condition of any of the 6 electrical power system batteries. After the explosion on Apollo 13, to get the astronauts home and alive safely, they had to either speed up the spacecraft or use less power. The first thing the crew did was to modify the orbit to speed Apollo 13 up and reduce the time to get home by 9 hours. That allowed the Apollo crew to safely get home on April 17, 1970. To see how they did this, join our Patreon page, Spacecraft Interactive Virtual Museum, whose link will be in the notes below. Thanks, Apollo Flight Journal, for supplying this information. Thank you for watching this episode all the way through. Don't forget to like, comment, and subscribe down below. And if you really like us, come to our Patreon page at Spacecraft Interactive Virtual Museum at patreon.com. Thank you for your support.